Solving trig equations. Okay, so here's example 1. 3 sine squared angle minus 2 sine angle minus 1 equals 0. Find the angle and the angle measurement that you find has to be between 0 and 2 pi. Okay, so when I look at this, I can't isolate anything because I have a sine squared and a sine. So this is a quadratic, so I'm going to try to factor. Obviously, if it doesn't factor, I can use the quadratic formula. So 3 sine angle is my first spot to get me 3 sine squared. In my last spot, I need to get 1, so 1 and 1 is the only way to do that. I can put a negative there to produce a negative 3 sine on the outside, plus sine. Okay, so now my solutions. Sine angle equals negative 1/3. Sine angle equals 1. Okay, I recognize this. It's on the unit circle. So sine is a y-coordinate. So that is a y-coordinate of 1 right there. So therefore, the solution for that angle is pi over 2. Okay, this is not on the unit circle, right? We don't recognize that value. So here's what we're going to have to do. This angle is in Astica quadrants 3 and 4 because sine is negative. Okay, I'm going to go into my calculator and I'm going to find my reference angle. But because this angle measurement is from 0 to 2 pi, they want the solution in radians. So I'm making sure my calculator's in radian mode, RAD, and I'm going to go second sine of, and I'm just going to use positive 1/3 because I'm applying the negative into the quadrant drawing. So the reference angle, and I'm going to go with 4 decimal places right now until I calculate my final answer, and then I'll go into 3. Okay, so how do we find the measurement of where this ends up? You're going to have to do pi plus 0.3398. Okay, so I'm going to add pi onto that. So that answer is 3.481. radians. Okay, and where did this one end up? It is smaller than 2 pi. Okay, that's a full circle, and then we're going to take off that many radians. So 2 pi subtract 0.3398, and you get 5.943. Okay, so we have 3 solutions, 1, 2, and 3. Okay. There's your equation, and you're going to find angle, and this time between 0 and 360 degrees. Okay, so in this case you need to isolate. Okay, it's not a quadratic, so we can isolate. So we're going to get rid of the 7 and divide by 5. Okay, now we've determined cos is a negative value. So in Astica, your angles would be in those 2 quadrants. And now our answer we're looking for, they've indicated to us that we're going to give that in a degree measurement. So now enter our calculator, we're in degree mode. We're going to coast inverse 3/5, but I'm leaving it as a positive value because the negative's in the drawing. It's 53.1301. Okay, so this one is smaller than 180 and this one's bigger than 180. So we have our angles to be 126.870, and the second angle is 233.130. Okay, what if it asks for find all general solutions? So if it had said what are the angles that solve for the angle and all general solutions, then you would have to state that your angle measurements for instance, this one, 126.870 plus 360k, where k is an element of the integers. And then same thing for 233, that you could add a rotation of 360 to that measurement, and you would have infinite many solutions. Okay? And simplify. Tan of 315 times secant of 240. Okay, so 315. So you have to visualize the coordinates there. So your coordinates are root 2 over 2, negative root 2 over 2 there. And when I do 240, I am, excuse me, right here. So the coordinates there are negative a half, negative root 3 over 2. Okay, so I got my spots on my unit circle. So the tangent is the y divided by the x. And when I take the secant, that's the opposite of my cos. So when I do opposite of cos, so opposite of cos would be taking the opposite of that x value, okay, because the r is 1, so 1 over x. It's taking the reciprocal of that. Okay, so that's what I have. You can flip here and multiply. And understand that everything would cancel, or you could have understood that the same fraction divided by the same fraction would be 1. Okay, and then so everything makes 1 there. I also know a negative and a negative cancel to be positive, so my final answer is 2.